For lesson 4.3, we're actually going to dive into functions, such as what is a function and what does it look like. A function is a relation in which each member of the domain is paired with exactly one member of the range, the input value and the output value. You can organize the input, rule, and output of a function using a function table. That's a whole lot of stuff. What it really is meaning is when I had all of my X numbers and all of my Y numbers, any number I have over on the right goes to exactly one number on the left. We don't have any sort of doubling up, such as 3 doesn't go to both 6 and to 4. If that green line was there, it's not a function. Functions work just like equations, where before we talked about y equals 2x plus 4 when we were graphing a line. The 2x plus 4 can be looked at as the rule of a function. The rule being, hey, this x number is related to that y number if you follow this rule. Meaning, if I take a -1, I plug it into this equation, or this expression, I should say, this rule, it should output, give me a number on the range. In this case, that would be 2. All I really, really want you to get out of the mechanics of this is with the rule, we're going to be plugging numbers in for x. Let's take a look at how to do that. I am going to jump all the way down to the actual exercise problems and talk you through some of these. To start, let's look at number 1. We want to figure out what is the function equal when I input a 1. When I take a 1 here and plug it in for x. X plus 3 is the rule. 1 is my input. So 1 put inside of x plus 3. What is it going to equal? We can show that by, let me rewrite that, by saying f of 1 equals, well, the rule is x plus 3, but instead of x, I would say 1 plus 3. And that is 4. Therefore, 4 is my answer. Let's take a look at that again. In number 2, it says f of 6. The function with the input of 6. So 6 is being plugged into 2x, and I want to know is what is the output? F of 6 equals 2, but instead of 2 times x, it's 2 times 6, and that is 12. Therefore, when I put 6 in as my input, the rule gives me an output of 12. At the lowest level, well, all we're doing is we are taking that number inside the parentheses and we are going to plug it in for x. Let's see. This becomes 20 minus 4. 20 minus 4 is 16. All right, at this point, pause it. Go back, watch that again. I know it seemed like it probably went really fast, but I want you guys not to get tripped up thinking this is something brand new. Plugging numbers in for variables is something we need to really deeply understand how to do. It's something you've been doing for a while, whether you realize it or not, and it tripped us up before, so I want to make sure we're getting it now. All right, number 4. In number 4, we want to know if I put 9 into my rule, or in this case, -3, but instead of multiplying by x, I multiply by 9 plus 10. You could plug that in your calculator. In fact, if you plug that in symbol by symbol, meaning -3, left parenthesis, 9, right parenthesis, plus 1, 0. Notice I said the parentheses. It'll spit out one answer. We should get -17. We're going to plug in for number 5 a -2. So 4 times -2 minus 1. 4 times -2 is -8. -8 minus 1 is -9. And one last time. In fact, pause this video and then try it out and then check your answer against mine. All right? Go ahead and pause it now. All right, I'm going to go ahead and write out the answer. F of -5. I'm going to have -2 times -5 plus 8. That should be 18. So that's all we're doing. We're replacing or plugging in numbers for x and seeing what does it equal once I actually solve the expression. Now, tables below are going to work exactly the same. I don't want you guys to get too messed up about the tables. We're going to use the tables again in the next lesson. The tables are a way of organizing our work. Now, one of the things not listed here is, well, what numbers am I going to use for x? I'm going to tell you honestly, you can use whatever numbers you want in that x column. I'm just going to copy what they did above. And for each of these tables, I'm going to plug in the following numbers. -1, 0, 1, and 2. And I'm going to use that as the x in every single one of these problems. All right, now that we got that out of the way, I want to try to slow this down a little bit. I know I went through that first part fast, but let's get to the meat of this. Above, all I did was took that number for x, I plugged it in, and figured out what was the answer. We're going to do that again. Take a look at number 7. Our x column's filled in, and now we're going to look at the rule. Well, in the very first row, if our rule is x minus 10, well, if that first row, x is -1, I need to look at what is -1 minus 10. And I am urging you to please, 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 unless you feel very strongly about your integers, when we take a negative and subtract, double check your calculator. We had a lot of heated discussion in class with the understanding that this is -11. We had a bit of a struggle with that, and I just want to make sure you guys are being careful. All right, let's do that again. Now with 0. Instead of x minus 10, I can say 0 minus 10. Well, 0 minus 10 is -10. All right. Now x is 1. Therefore, it becomes 1 minus 10, so that's a negative 9. And then we have 2 minus 10 is negative 8. All I'm doing is plugging in a number and moving along. Once I plug in my number, all I have to do is follow the order of operations. It's not meant to be super confusing. As long as we're strong with our order of operations, this should come pretty easy. Let's look at number 8. Number 8, we're going to have to do some multiplying and some adding, so be very, very careful. We have this negative 1 first. So instead of saying 2 times x, it's 2 times negative 1 plus 6. Well, I know 2 times negative 1 is negative 2. So you check, what is negative 2 plus 6? We should get 4. So the order of operations here, I had to multiply before I could add. Let's look at that again for 0. 2 times, well, that blank should be a 0. And then 2 times 0 is 0. Plus 6. 0 plus 6 is 6. Now, I have 2 times x, but instead of x, I'm going to plug in my 1. 2 times 1 is 2. 2 plus 6 gives me 8. All right. So we're getting there. One last one. Again, 2 times x, but instead of x, this time we're told we want to plug in 2. So 2 times 2 is 4. And then plus 6, I should get a final answer of 10. All right. This next one is something I want you to be careful about, because I've already noticed some mistakes people are making in the order of operations. So I've got a lot of clear space over on the right. I'm going to write all this out to make sure we get the pattern. Now here, our rule is 2 minus 3x. So in that middle column, I'm going to start with 2 minus 3 times, well, that blank should now be occupied by negative 1. I'm going to go off on the side here. If you're using your calculator and plugging in every symbol you see I have written, you should get the same answer we get by doing this by hand. Now, I need to look at what happens if I have this negative 3 here multiplied by negative 1. Negative times a negative is a positive 3, and I bring down my 2. And 2 plus 3 equals 5. Therefore, my first blank in the right column is 5. Next, 2 minus 3 times, instead of x, I am going to plug in a 0. So 2 minus 3 times 0. If I take this negative 3 here, times it by 0, that's just 0. And I bring down my 2, because what is 2 plus 0? Or, as many of you might say instead, minus 0. It should still be 2. So 2 is my answer here. Next, 2 minus 3, but instead of times x, it'll be times 1. So off at the side, I look at 2 minus 3 times 1. Well, 3 times 1 is simply just going to give me 2 minus 3. If I have 2 and I take away 3 from it, I should get a negative 1. Now, I'm going to let you finish this last one. Pause the video. Try out the last rule. Plug in 2 for x and see what you get. Pause now. All right, when we go to fill this in, 2 minus 3 times 2. Well, that's 2 minus 3 times 2. We know 3 times 2 becomes 6. That's a negative times a positive, so it became a negative 6. 2 minus 6 is negative 4. Use this as a way of reviewing what we did for that lesson and use it as a guide as you are working on this practice.